Hello everyone. This is the video lecture for college algebra, math 1414, section 5.3, more trig. At least that's my title. We're going to see all kind of things in this section, and I'm going to try to go a little bit faster than normal because it's so long. But there's really nothing new yet, so at least let's do this. So 531, I have a point negative 10 comma 24. Again, that's an xy point, and they're wanting to know the angle, not the angle, the sine, cosine, and tangent of that angle. So we got my point P out here. This right here, this way is my theta, and they're wanting to know what is sine of theta, cosine of theta, tangent theta, all that kind of stuff. Well, okay. How do we do it? Well, I see this right here as a triangle. And so then we have my point P is again an x and a y value. Notice that we're going a negative 10 distance this way, but we're going up 24. What I need to know is what's my hypotenuse. I'm going to use Pythagorean theorem. Here's a new one for you. Let me just give you one. R is equal to the square root of x squared plus y squared. And this is my R. And so, putting it in, I've got negative 10 squared plus 24 squared. When you do the math and the square root, put it all in the calculator, I get a 26. So that's my hypotenuse, is 26 now. Okay. And this is my angle technically, but you can think of it kind of like that one right now. It's totally fine. So let's get this going. I'm going to redo my sine, cosine, and tangent not as opposite, adjacent, hypotenuse anymore, but instead as, this formula's for you, y over r, x over r, and y over x. They're the same thing. But notice that I have an x, I have a y, I have an r. And if I follow this format, it will be very quick to get my answers. 24 over 26, you're going to reduce it down to 12 over 13. X over r, that's a negative 10 over the 26, reduce it down to negative 5 over 13. And finally, y over x, I've got my 24 over the negative 10. If you reduce it down, you get a negative 12 over 5. That negative, again, could go into both the top or the bottom. It doesn't really matter, as long as you got it, as long as your answer is negative in the end. Well, that's it. And then you take these and you flip them to go get your secant, cosecant, and tangent. Very similar to what we've already done. I'm not going to do it. I don't really care. Because that's not the big point here. The big point is that we're learning this sine, cosine, and tangent with x, y, and r. Let me redo it a little bit here, okay? So I got my sine theta is equal to y over r. I like this very much. Well, there's this thing that we're going to learn now called the unit circle. And unit means r is equal to 1. Try to rewrite that. R is equal to 1. Unit, 1, single. And so if that's the case, couldn't I rewrite my sine as not y over r, but y over 1? Couldn't I then rewrite my sine as y? And then similarly, similarly, my cosine would be an x. I like these. I like those a lot. Now that's of course for the unit circle. And still, my tangent is y over x. Have I seen this before? Let me just rewrite this. Y over x. How about a rise over run? Surely you've seen that. It's slope. It's slope. Your tangent is equal to the slope. Pretty nifty, huh? Let's do this thing. 5, 3, 9. It says find the sine of pi over 2. Huh? What they're wanting is the y value. At what angle is that? Can you convert it? Blah, 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 convert it. It's 90 degrees. Very good. It's straight up. So I'm going to ask, hey, on the unit circle, that means my radius is a 1. Radius is a 1. What is my y value up here? That's a 1. Because it's straight up, and that's the radius, isn't it? Isn't that my radius? And it's straight up, and my radius is always a 1. Just a thought there. Well, that's pretty easy, I guess. If you look at, if you actually have a unit circle and you pull it up, you'll see that there's a point up there, 0, 1 in particular, and they're saying, what's the y value? I don't know if I'm explaining it enough. I feel like I am, but then again, it just seems all so new. Like, wow, you just pull out a 1 somewhere. Well, yeah, I did, actually. I did. Tangent of 3 pi over 2. What's the angle for that? Give me some degrees. What do you think? Do the math, convert it. I'm going to let you do that. It's 270. Wow. 270 is straight down. Straight down. And so tangent is, again, my slope. Look at this for a second. What's the slope of this line right here? Here, let's make a vertical line. I'm going to ask, what's the slope of that thing? And you're going to say undefined. And you would be correct. You're done. Undefined. You click undefined or something or other. I don't know. Whatever my math lab says to do about that. Okay. 5, 3, 15. I've got tangent of 0 is equal to what? This is also pretty easy here. Again, I'm looking at my slope, but now at 0. 0 degrees is over here. 0 radians, 0 degrees, both the same. What's my slope of this line, this flat line? What's my slope? Nothing, no slope. It's 0 slope. There you go. Couldn't you have used a scientific calculator to get all this stuff here? Yes. That's another option, of course. And for undefined, wouldn't you just get in like an error or something? Just a thought there. Okay. Here's one I got. Tangent, tangent theta is less than 0. And then it says secant of theta is less than 0. And it says, what quadrant are we talking about here? Quadrant what? That's kind of weird. Well, remember that this is slope. My slope is negative. And remember that secant is 1 over cosine, right? Which is basically my x value. And my x value here is also negative. So let's kind of find out where's my slope negative? Is it right here? Is that a negative slope? No. If you have a line like this, that's a positive slope right there. A negative slope looks like this, right? Going down over time. And so if you want to put it in quadrants, it's quadrant 2 and quadrant 4. That's where you have a negative slope. Okay, what about your x value? Where's your x value negative? Well, it's over here, quadrant 2 and quadrant 3. These are negative x values. Where do they overlap? That's the key trick here. They overlap in quadrant 2. I put the @ sign because I want to be cool today. Quadrant 2, and that's your answer. It's actually really simple. Let's do another one. I got 5, 3, 21. I've got tangent of theta is less than 0, and I have my cosecant of theta is greater than 0. So I'm saying that my slope is negative, but my y value, again, if you remember, this is 1 over sine, which is a y value. My y value is positive. So over here, negative slope is over here and here. Quadrant 2, quadrant 4. My y values are positive here in quadrant 1 and quadrant 2. Where they overlap, there you go. Next questions. Got plenty more to do in this section. I have the cosine of theta is equal to negative 24 over 25. And it says, this is in quadrant 3. So now, find everything else. Find the sine, the cosine, and a tangent. The sine, cosine, and tangent. And then, of course, after that, you also need to flip them and find the other 3. Oh, well, you got at least one of those answers. I cannot remember if MyMathLab actually has a box there where you have to type it in again. So if it does have a cosine box, go ahead and just retype it. It's like a free answer there. If it does not have it and it's just missing, just be careful so that you're not typing what you thought is cosine into a tangent box or something, okay? I'm going to put it there just in case, but watch out. It might not be there. Kind of depends on the problem. Okay, so like, well, what do we do? Well, first off, quadrant 3 is down over this way, right? And so I'm looking at a triangle that looks something probably like this here. Also notice cosine, that's going to be an x value. Or you could even go a step further and say that this is my adjacent and my hypotenuse. I mean, it's okay to go back and do that sometimes too. So negative 24, got a 25. Well, I'm going to do the Pythagorean theorem to find the y value here. And let me go ahead and give it to you. Y is equal to the square root of r squared minus x squared. It's just a manipulation of the Pythagorean theorem that we already had. I just keep using the same old thing. It's just now it's a minus sign because I'm finding one of the opposite or adjacents. And if you did the math too, you would see it. I'm not going to break that down right now. We got too much stuff to do. Again, what I'm saying is, trust me on this one. Notice that we got negative squared, so that's 2 negatives, make a positive right there, but it's still a minus sign right here. So ultimately, it'll just be one single minus. I got the square root of 49, which is equal to 7. Now I'm going to ask a question. Is that a positive 7 or a negative 7? Well, didn't I say last time that whenever I did the square root, just keep the positive one, right? Because it was distances and stuff like that? Yeah, hold on. We're talking x and y values. Notice that my y value is down here in quadrant 3. Negative. Negative. How did I pick negative? Because it's in quadrant 3. That is literally the only thing I have got going for me. There's nothing else. I can't just say, well, I've just chosen it because of what. No, it's quadrant 3. It's right there. It has to be the negative. So that's my y value. And so now I can use this here. Again, this was y over r. And so then I got my negative 7 over the 25. This is y over x. So I got a negative 7 over a negative 24. Again, 2 negatives will make a positive, of course. And then you flip them. I'm not doing the flip. I don't care that much. I know you can do it because you've gotten this far in the class. You can definitely flip a fraction. Oh no, he's skipping steps again. Tangent of theta is equal to negative 2/5. Cosecant is less than 0. Figure out all the sine, cosines, and tangents. Okay, so remember that this is y over x. And so I go immediately and say, you know what? I got a negative 2 for y, but my x is 5. 1, 2, 3, 4. Yep, there we go. Somewhere over here. There's my angle. Or I guess you can technically just make a triangle right here is good enough. Okay, so then I got my negative 2, and I got a... Oh, why did I say a Back up, back up. Okay, seriously, back up. Hold on. Whoa, whoa. Negative 2 for my y. Actually, you know, I think I probably was not doing a bad thing. Negative 2 for y. It's my y value, isn't it? Hold on, where's negative 2 for y? It's right there, negative. Gosh, just erase everything you were doing. That's why you're going to watch the recording to the end, right? I was talking about other things. Forgot about this. So then I got a positive 5 for x. 1, 2, 3, 4, 5. Okay. But I want to redeem myself just a little bit, because this is actually important. I have a question. I was thinking something differently, but I was doing the right math. Let me show you why. When I say negative 2/5, you think, well, it's negative 2 divided by 5. That's correct. Couldn't it also be 2 over negative 5? Isn't that equivalent? And so wouldn't I then have a positive 2 and then a negative 5, a positive 2y and a negative 5x? That's what I was doing. I was going positive and negative 5 for x. My point is that we have this one or this one, and I don't know which one it is. It doesn't say. It just says negative 2/5. That's it. So it's going to be this one or this one. So I got a negative 2 for y, or I got a negative 5 for the x. I don't know who has the negative. They didn't say. But then they have this. And they're saying then that's, again, cosecant is 1 over sine. Look at about basically my y value. My y value is negative. Negative y values are down here and down here. So obviously you can see that my true answer is going to be this guy right here, not this one. So I'm looking at this triangle now. And now you can see why I was doing this one. I was thinking that the negative was whatever. Maybe I didn't say it. I don't know. Dyslexia. It happens to all of us. So, seriously. And so I have my little triangle here. And I need to put my y and my x and all that kind of stuff. My y was a negative 2 and my x is a positive 5. Well, what's my my radius? What's my r? R is equal to the square root of 5 squared plus negative 2 squared. 25 plus the 4 square root 29, which I do not think actually reduces. So we're just stuck with that. That's fine. Okay, given that I have this, now find the sine, find the cosine, find the tangent. Well, sine is y over r, and so then I have a negative 2 over the square root of 29. Sadly, they're not going to accept that, so you need to pop that up and leave the number behind. Rationalize denominator. My x is a positive 5 over the square root 29. Yet again, they will not accept that. So rationalize denominator. And finally, y over x. We already had this, actually, negative 2 over 5. And there we go. Now, what you do for the other 3 is you flip it. Normally, I just skip this. But this time, I'm actually going to do it. Because there's that radical in there. The square root. I'm going to flip this thing. No, I'm not. I'm going to flip this guy. Because what's going to happen is I already have it rationalized. Notice that I had a negative 2, but then I put the negative up in the top. Doesn't matter. Negative 2, negative square root, as long as there's a negative, you can put a negative in the front. And that's kind of my point here originally. Again, I don't know which one it's going to be. Is it a negative in the top or the bottom? I don't know, and it doesn't really matter. For this one, I'm going to flip this guy. Flip it. 29 over the 5. And then this guy's easy to flip. Negative 5 halves. Okay. Cool. I'm kind of glad when I make mistakes sometimes. For one thing, you can see that I'm definitely a human. That's a good thing. Okay. Find the reference angle for 130 degrees. What is reference angle? Let me give you a definition. Reference angle is an acute angle with the x-axis. I want to say coterminal. Sorry. Coterminal, but that's not exactly right, I don't think. It's an acute angle made with the x-axis. Let's talk about it. So 130 degrees is somewhere over here. I do not know exactly where. It's somewhere over there. 130 degrees right there. Well, what I want to make is an acute angle. Acute means less than 90. Less than 90 degrees. And so that would be this little guy right here. That's my reference angle. How do I find that little guy? Well, notice that we definitely have 180 for the full half circle. So then I could say my 180 minus the 130 should yield that little acute angle. It's 50 in this case. Cool. So it's very simple. Just line it up with like a 180 or a 360 or something, and like physically look at it, and then just subtract or something like that to go and find the actual answer. Reference angle for 5 pi over 4. Well, they just had to throw some radians at us. Where is 5 pi over 4? If you do the math, it's actually down here at 225 degrees. So we're talking this right here. The acute angle made with the x-axis, do you remember it? The x-axis is actually right here. And remember that this is 180 over here. Do I subtract? Yes, but I subtract like this to make 45. They're not going to accept this because they want radians. So is there another way to do this? There's actually two ways to do this. I would say what you have right now is actually really good. You can convert that into radians by using a formula. That was easy. Again, multiply by pi over 180 or 1 over pi, whatever it is. You could also just start and end with radians to begin with. And so this right here is the 5 pi over 4. And this is just pi. And so then I could subtract them like this. Remove the pi. Calculator, whatever you want to do. It's 1/4. There you go. Just another way to do it. 5, 3, 47, I got a reference angle for negative 325 degrees. Where's negative 325? Well, this is negative 360 technically if I'm going, clockwise. So it's pretty close. I want the acute angle with the x-axis. Again, the x-axis. Always the x-axis. I don't really know what that would be, but I think they're related somehow. What if I did 360 minus 325? Right? I get 35. That'll do it. Is 35 right here? Does that make sense? 35? Does that look like a 35? It's not negative, is it? No. Here's another one. So many problems. Cosine of 210. Find the reference angle? That's weird. Think about this for a second. They say find the reference angle, but then they actually just want to know what the cosine is equal to. This is honestly a little irritating because if you just go to your calculator, you'll find something or other. But why do I have to do this reference angle? They're wanting you to use unit circle and all this kind of stuff, and that's okay. Let's just go through it. Let's figure it out. So reference angle for 210 is somewhere over here is 210. Acute angle right here. That's the 180. So I'm going to subtract the 180 this time to find that small little angle, which is 30. So what they're actually wanting is cosine of 30 degrees. I'm figuring that they're wanting you to use like a legitimate unit circle, but and that's fine. Unit circles are great and all, but surely there's another way. Well, I guess a calculator kinda. I'm going to use the unit circle. They say unit circle, let's do the unit circle. I don't know what that is. Here, let me zoom out. That was a mistake. Oh, now I'm zooming in. Hold on. Okay, that's better. Sorry. Okay, let's start over. Unit circle. That's better. 30 degrees. You have a point here at 30 degrees on the unit circle. If you pull up a unit circle, what do you have? You got a point right here. And it is, trying to remember here, square root 3 over 2, comma 1/2. Oh, man. I just remember how they want you to go about this. It's just loony land sometimes. So it's okay. It's okay. Cosine is an x value. There's my x value. This is an x and a y. So it's got to be a square root 3 over 2. But you put that in. Actually, you put that in and it says you're right. No, wait. It says you're wrong. Why are you wrong? Because originally we had to find this 210. Notice that my x values over here are negative. And so then this is technically just a negative square root 3 over 2. Let me do one more like this, and then I have an idea. I just get disappointed whenever they just kind of say, use a unit circle, and then, like, later on in pre-cal, they're going to say, well, now you can't use the unit circle. But then all of a sudden, I thought I was supposed to learn this thing and learn using it. I guess. Find the reference angle. Okay, so we got 7 pi over 4. And I don't know where that is. Where's 7 pi over 4? I can convert that into degree mode. Convert, convert, convert. Oh, it's 315. Oh, okay, it's over here. Reference angle would be right here. And this is 360, so what if I subtract those? 360 minus 315 is 45. So there's your answer for the reference angle. So they're really saying, hey, find the cosine of 45 degrees. Find the cosine of 45 degrees. And if you go up to your unit circle and find right here at 45 degrees, you will see a point P at square root 2 over 2, square root 2 over 2. This is an x and a y. Cosine is an x value. So you're going to use that number, and that is your final answer. Now you're thinking, but wait, could it be a negative? Could be, but if you go back and look at my original, notice that x values are positive over here, and so we're definitely going to get a positive in the end. I just don't like how they're teaching it. They got another one like this? They got a whole 2 or 3 more like this. Let's do something different. Let's do something different for a minute. Okay, first off, let's talk about reference angle for just a minute, okay? Reference angle. There's a formula. I don't want to know if it's a formula. It's more like a form. Anyways, if you have an angle over here, your answer for the reference angle is simply theta. If you have an angle over here, what you're going to do is say 180 minus that angle. Like, for example, let's say that you had 150. 180 minus 150 would be 30. If you're down in quadrant 3, you're going to take theta minus the 180 and find your answer. This is how you find your reference angle. And then finally over here we got 360 minus the answer, or the angle that they gave you. So that's cool. It's kind of like a formula. But those are all in degrees. What about radians? So then we got theta again. It's like, hey, I have 30 degrees. What's the reference angle for 30 degrees? That's 30 degrees. It's already done for you. So there's nothing to do there. Of course, 180 is equivalent to saying pi in radian mode. Theta minus the pi. And then, of course, 2 pi for 360. So that's your degree in radian formula for reference angle. Find out what quadrant's in. Whatever quadrant you have, cool. Just apply this thing, and then you're done. You don't have to reason. You just look and plug it in. I like plug it in. Let's do something else. Let's talk unit circle for a minute, okay? I like unit circle. Everybody likes unit circle. You might not like the unit circle. We got 0 degrees over here. I have a point at 1, 0. I also have 90 degrees here. And then they have a point up here, 0, 1. Of course, we also have a 45 degrees, and they give me a point there as well. And that's square root 2 over 2, square root 2 over 2. Here's another one, 30 degrees. So that's square root 3 over 2, comma half. 60 degrees, last one, 1/2, square root 3 over 2. They're assuming in this section that you have that memorized already. I'm not. So we're gonna kind of work around it, but there you go. Take a snapshot of this, and let's kind of break it down a little bit. Notice that we got our x's and y's, right? X's and y's, and so x and y is equivalent to cosine and sine. Those are your cosine and sine values. And of course, we already know that tangent is y over x. I did not want to zoom. Back up. This is very picky stuff. You don't want to zoom right in the middle of your lecture. It's y over x. And so you take your y and your x and divide them. Okay. Cool. Can you memorize this? I know you can. I've memorized all 4 quadrants, not just this one. What these previous questions are trying to get at is that, hey, if you have quadrant 1 memorized, well then you just change the sign to whatever you need. Okay. Well, that's one way. And I agree with this. I like this. Please do this. And I did those 2. I'll do the others as well, just as they're saying. Because I'm supposed to be a good teacher. But there's also something else that we can talk about. With your scientific calculator, I want you to try a couple things. I want you to put 1/2 in and see what decimal equivalent it is. Okay, 0.5. Very good. You actually did that, right? What about square root 2 over 2? Type that into the calculator. You're going to pause the video, right? Pause. Unpause. It's 0.7071, right? Here, let me just verify myself. I have these memorized. It's always good to have it, make sure that we do it right. And then I got square root 3 over 2. 0.866. And again, let me just verify that. What I've done is I've memorized these. When I see decimals that are 0.5, 7071, 866, I know I've seen them before. It's kind of like if I saw 3.14, 159, it's a pi, right? That kind of stuff. So these guys are my x's and y's for all this unit circle stuff. So let's go back to one of the questions we just did a second ago. Hold on. Let me go find it. It's a great question. The last one said, find cosine of 7 pi over 4. I'm going to type that into my calculator. Make sure you're in radian mode. Here, do you want me to write that down? Radian mode. Type that in your calculator. Sorry, I was just changing my mode. Cosine 7 pi divided by 4. And I got, like from my calculator, 0.7071. I wonder what the answer is. Oh, yeah, it's square root 2 over 2. Okay. Surely that doesn't work every time. Let's try the one before it. Cosine of negative... There was no negative, I'm sorry. It was 210. Type that guy in. Oh, remember? Degree mode. I almost messed up myself. Put it back in the degree mode. Cosine of 210, enter. And I got negative 0.866. I wonder what that is. Notice, negative. They're already telling you the answer. You don't need the reference angle. Okay, glad we talked about that. You do need to know the unit circle, because these right here, that's nifty. It's a nice trick, and it works. But I wouldn't rely on it. Not everything is so simplistic. Here's a great example. I got cosecant of 7 pi over 6. And it says, find the reference angle. Now, I'm getting tired of the reference angle myself. I wish I could teach this a little bit differently. I got full unit circle capabilities here. But I'm trying to be good, and I'm following the steps. Apparently, this is actually an answer that we need to find. 7 pi over 6. Well, pi over 6 is just a little guy right here. That's 1 pi over 6. This is 2 pi over 6. This is 3 pi over 6. 4 pi over 6. If you reduce them down, you'll see that's a pi over half. 5 pi over 6. 6 pi over 6. What is 6 pi over 6? Reduce it down. What do you get? Pi, right? That's easy. 180. Finally, 7 pi over 6. We're right here. We're in quadrant 3. Oh, yeah, I have a formula for that now, don't I? I'm going to take my angle, and I'm going to subtract pi from it. By now, I hope that you've learned that you do not use a pi in your calculator like that. Okay, we got the reference angle. Oh, right. Good job. What they're wanting you to do now is saying, oh, well, pi over 6 is over here. We know this point on the unit circle. It's square root 3 over 2 comma half. You got your x and your y. Well, what they were wanting originally was the cosecant, which is 1 over sine, which is 1 over y, and so then I flip it, and I get a 2. Nice! And why? Because it's actually down here in quadrant 3. Didn't we just say that a second ago? My y values, if you notice, are actually negative. So yes, it's a 2, but rather it's a negative 2. Yay! All right, cool. So on your calculator, what are you going to do? 1 divided by the sine of 7 pi over 6. Notice that I don't have a cosecant button. If you have a fancy calculator, it's probably not allowed, but you can always do this. And yeah, I don't know, the 15.64307. Wah 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 wah. Right? Wrong. You need to put it in radian mode. Right? If you get something wonky, that's not the right mode. Look, calculator, -2. Compare and contrast, please. All of this talk and blah blah, reference angle, find this, and then I have to get it wrong just to go ahead and get it right when the calculator gives it to me the first time. Next question. Sorry. I am just a slight bit irritated, but not at you. Just at the repetition that they continue to do this, and that's fine. It's good practice. It's always very good practice. Okay. You know what to do. And I'll see you in a couple minutes after I officially make my teacher speech. 675, where is that? Well, this is 0. That's 360. Yeah, I don't know. It's somewhere down here, maybe over there. Somewhere around here. I have no clue, but it's too far for me to know. And so I'm going to subtract 360 to make it coterminal and find out something that's a little bit better. Now, here's an often asked question right here, and it's interesting. Oh, wait. Sorry, I redid something wrong. I mistyped. Hold on. Okay, there we go. Okay, Now, hold on. I'm still in radian mode, but I put 675 minus 360. Is that going to be okay? Yes, because you're just doing numbers. The radian and degree mode only affects sine, cosine, and tangent, not just normal algebra math, you know? 315. It's right down here, quadrant 3. Cool. The reference angle is this guy right here, and that's 360. We're going to now say 360 minus 315 makes a 45. Cool. And then I say, you know what? I remember 45 on my unit circle, my little quadrant 1 stuff here. That was the square root 2 over 2 and a square root 2 over 2. My x and my y. Oh, and secant. Secant, I remember secant is equal to 1 over cosine, which is 1 over the x value, which is now 1 over the square root 2 over 2. Cool. Oh, yeah, and then I flip it. 2 over the square root of 2. Oh, but my math lab wants to simplify it, so then I pop it up and leave the number behind. Because I have a 2 over 2, I can cancel it and leave it like this. Now, do I get it right or wrong? Hold on. Remember that I was looking actually down here in quadrant 4. But I was looking for my x value, which is positive over here. I should expect a positive answer, and I do have one. Cool, so I don't have to change anything. You're done. 1 divided by cosine of 675 in your calculator. Make sure you're in degree mode. I am not. I need to change my mode. So 1 divided by cosine of 675, enter, and I got 1.4142. That is not on my list. See my little list I made way up here? Where's my list? Right there. Right there. There's my list. It's not on my list. 1.414. Ugh. Impossible task. I know you see the answer already, so you already know that's going to be a square root 2. Notice that it's positive. At least you can gather the sign, SIGN sign, from this. So I'm trying to say that, yes, your calculator's great, and it'll tell you most everything, but it didn't here. That is, unless you've memorized what square root 2 is, and that's fine. I agree that memorizing that is a good thing. There are times when we're going to get strange answers. Here's one for you. Let me just say I got blah blah into my calculator and I got a 1.1547. I mean, you know the square root of 2, right? Well, I have no clue what this thing is. No clue at all. I've literally, between you and me, not ever seen it before. Yeah, it's 2 over the square root of 3, which is 2 square root 3 over 3, which does sometimes come up as some of the answers. Your calculator's not perfect. It's going to give you weird decimals sometimes. And, you know, we can either work around it, we could try to flip it, or something. Both methods have some value. All right. Moving on to a new problem set. I've said that this is a casual lecture experience, haven't I? I have a cosine of theta equal to negative square root 3 over 2, and it says find 2 radian values that make that work. Basically, theta equals what, and I need, like, first one, second one. And they want them in radians, comma separated. Okay, so here's what here's what I'm thinking. I've seen this before. Square root 3 over 2. Remember that this is an x value. And out of the 3 that I have one, no. I got square root 3 over 2, 1/2. Square root 2 over 2, square root 2 over 2. I got 1/2. Yeah, 1/2. Square root 3 over 2. Okay. for my 30, 45, and 60. Very good, very good. Okay, so I want the x value to be this guy. And there we go. So we're talking 30 degrees, but not really, because there's a minus sign right there. Where is my x values negative, right? X values are negative this way in quadrants 2 and 3. But somehow I'm supposed to be using 30 degrees. But I can't use 30 degrees. What I use instead over here is 150 degrees. 210 degrees. Cool. Notice that again, these are my reference angles. My reference angle would be the 30 degrees for both of them. And cosine is negative. Awesome. So I'm going to take these now, and I'm going to convert them into radians. Thankfully, they're easy ones. I got 5 pi over 6 and 7 pi over 6. And that's basically how you do this problem. What if I used a calculator? Right? Think about it for a second. It said the cosine is equal to the negative square root 3 over 2. Couldn't I arc cosine? Couldn't I go and find the angle for this? Okay, let's do it. Arc cosine of negative square root 3. Oh, pressed the wrong button there. Negative square root of 3, and then divide by 2. And I've got, wow, in degree mode that is, I got 150. Nice! And I already know that that's 5 pi over 6, so I'll go ahead and put that in. All right, cool. We're done here, right? Whoa, 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 whoa. How do you find the other angle? In a way here, I'm saying it helps. It'll give you some. But we have to do a little bit more math, a little bit more reasoning. I would suggest doing both. Use your calculator, at least to help you out. Give you a hint once in a while. Sometimes it'll just be done, and you don't have to worry anymore. Sometimes we got to reason through it a little bit more. This is actually the last question, thankfully. So I got negative square root 3 is for my tangent. And we've already discussed this. This is y over x. So could I have a negative square root 3 over 1? Or do I have a square root 3 over negative 1? Either one could work. Here's another problem that I'm having. I don't see these on my unit circle. Every time I see a square root 3, it's always divided by 2. So I don't see those. I don't know where to start. I mean, it's close. Because you always see that square root 3 over 2, and because this is technically a y over x, they're two separate values. Like here, let's just take this guy for an example. I think it's the wrong one anyways. X and y both have a divide by 2 in there. Same thing up here, which I think is the correct answer up here. They both divide by 2. So what I'm going to do is I'm going to take these guys and say, you know what? I'm going to divide by 2 on both of them. Just like that. You should be getting 2 answers, by the way. This guy and this guy. Both of them could work. I don't know where they are. So I'm thinking that my y value is this, and this is my x value. Y value is the square root 3 over 2. My x value is the 1/2. You can see that this angle right here, 60 degrees, is actually your answer. 60 degrees. That's what we're talking. But wait! It's negative. And if you remember, tangent is equal to slope. Slope negative means quadrant 2, quadrant 4. But because my reference angle is 60 degrees, it's actually right here and right here at 210. If you go all the way around, this is at 300. Those are my 2 answers. Either one could work. In radian mode, this right here is 2 pi over 3, and this here is the 5 pi over 3. Those are my answers. if the last few questions seem like a whirlwind, they are. They are. I would recommend having a full unit circle available for you to look at. In particular, let me do this problem with a full unit circle. None of this reference angle stuff. I want to just do it. And if you go through this whole entire unit circle, there's going to be a point right here that says it's -1/2 and positive square root 3 over 2. This guy right here is a positive 1/2 and a negative square root 3 over 2. We had already concluded that it could be either way. Do you remember that? So I'm looking for y's being square root 3 over 2. I'm looking for x's being halves. And I look around this entire unit circle and I find them right here, y and x. You also find them here and here, but they're either both positive or they're both negative, and we've already said that those don't work. One of them's got to be negative, and one of them's got to be positive. I simply then look at my unit circle here, and I get the answers immediately. Lots of ways to do this. Could you use the calculator? Yes. Could you use all kind of things? Yes. I'm going to suggest, this is the end of chapter 5, we're done here. I'm going to suggest that it's a good idea if you go through it yourself. Go through it, have a unit circle, have a calculator, see what works for you. And then you can ask me questions as well. I don't mind. I'm always around. And we can work on it together. So, the chapter 5 has a lot of homework questions, especially this last section here. But they're good practice. That's the idea with homework. You're doing homework because you're needing to practice doing it. If you don't practice, you can never master that skill. You can read about it all day long, but you actually have to do it in order to actually learn it. And I, personally, as a teacher, say that you have to make mistakes to learn. And that's okay. There's a lot of mistakes to be had. Didn't I make my own mistakes? So, there you have it. Now you have some philosophy with some math. Thank you very much for listening, and have a great day.